think we are good now. So I was having challenge recording. So good morning, everyone.
Good morning.
Who has joined us, who is a part of this training. We appreciate you for joining this training and then for the willingness to also improve your skills and learn about this software. So I just want to do a brief introduction about our facilitator today. Though I've introduced him in our first class. However, I think it will it won't be nice if I don't talk about his person to some of us that are new to this training and its impact and its influence in some of the things we do. So what we are seeing now is not something that is new. It's something that we have started before now. Training young engineers in different areas of HVAC, as far as the Nigerian market is concerned, and also Africa and the world at large. So he's an engineer with experience. I can introduce him off the top of my head, so I don't need to look at book. With experience over 20 years or 25 years in this industry. Like I wrote in one of my LinkedIn posts, his experience has transcended different versions of Revit from as far back as Revit 2009. You know, I started using Revit, I think 2015. You see the gap. You see there's a wide disparity. You understand? And he has transcended different generations, different things as far as designing of HVAC system, mechanical system, electrical system, and plumbing system is concerned. So it's an honor that we are having him here. And what he's doing, what I'm doing now, or what we are doing in B-Scope Academy is an extension of the work he starts. You know, like they said, that there's no invention that is new. What you just need to do is that, you know, the way we do projects when we are as engineers, what we do is that we read the literatures of people that have gone ahead of us, add one or two things. There's no new innovation, so to say. So what we are doing is an extension of the work he has started. And then again, he's also still willing to support this work and also promote this work. So I think we need to do something for him today. I'll look at my time. We will clap for him for 1 minute. You have to start clapping your hands for him for 1 minute. Please, both the physical and the online people.
That's not necessary. We have a long day to go. Let's start right away.
So he has told me to stop. He's my father in the industry, so I have to listen to him. Thank you so much, sir.
I think we have Engineer Olawande who want to quickly say something. Yeah, you can unmute your mic and speak. Maybe, okay, press that in error. Okay, good morning, everyone. Thank you. I see all the clap, I see all the thumbs up, I see all the appreciation. Thank you, and I appreciate you all for making out time to be here. My wish or my hope is that the whole of session we are going to have today will not go into waste. I wish and I believe that everyone will grab one thing or the other from this class. Okay, while I'm going to start, I like giving a small pep talk. I wish we were together in a physical class. I would have given us an exercise to do, a physical exercise that lets you understand the challenges that comes with change. When we talk about change, meaning, yeah, there's something I'm doing, I'm good at it, I know how to do it, but now I need to do it in another way. The same thing that I'm doing, but I need to do it in another way. Because I'm comfortable with one old style of doing things, the new method will look so strenuous and look so time-consuming. So I can easily flip back. I can easily switch back. Let me see if I can do a short exercise. If you can see me on video, can every one of us fold our arm like this? Though I cannot see you, but try it. If you fold your arm like this, the moment you fold your arm, that's your comfortable way of folding your arm. You don't need to think about it. When I say fold your arm, there is one way that's comfortable. So when I do this, you can see my right hand is on top here. My left hand is beneath. Now, let me try to change it. Change it in the sense that, you see, when I want to do it, that comfortable way is coming again. When I say change it, it means this should go under and this should go on top. So it's not comfortable. But when I say fold your hand, this is the comfortable way. So if every one of you try it, I know you will see what, you will understand what I'm saying. When I say fold your hand, there's one way that is so comfortable. Then when you try to reverse it, it becomes a struggle. You are not getting it. Can somebody confirm this to me? Tried it. Can you confirm it to me?
Exactly,
Yes,
sir. Exactly, sir.
Okay. So that is the way I want you to see Revit. There is a way you've been working, yes, which you are comfortable, you know it, you have mastered it. This other way, still doing the same thing, but proving difficult. There will have been some other type of physical exercise I will have shown you to see what change means. But we must be passionate. We just have to decide, okay, I want to get it right. So we move to the discussion of today. So for every engineering innovation, there's usually a theory. I mean, the theory will precede the engineering innovation itself. So usually it comes out of physics, if I am not mistaken. I hope we can see my screen and we can still hear me.
we can hear you. But can you, this small tab, can you close it, sir?
I'm
Close
looking.
it,
I'm looking at how to close it if I will not sign out. Am I still on? Okay, good.
yeah, you are still on. You are still on.
Okay, so the physics part is what we want to look at now. So what is the objective of this training? We want to understand the workflow of energy analysis in Revit, how we create the architectural model, how we convert it to mass, how we set up the energy setting, and how we analyze, then we can do simulation and get our results. Also, in this class, we're going to see how the analytical model is generated from the geometry, the architectural file that we have. We will also now learn how to run energy analysis using OpenStudio simulation platform, then how to interpret our results and how to size our equipment correctly. And this we will do with guide, as the direct hands-on guide. Okay. So the foundation, like I said, there's always a physics to every engineering innovation. We need to learn what is the context of our site, the climate data, the conceptual data of our building, and the content in the real elements and detail. We need to understand that in the foundation. And we will now proceed after that knowledge to execute the model in terms of zoning, system analysis, and reviewing our results. So what do we mean by energy analytical model? It simply means our building being converted into thermal volumes so that we can do energy simulation. What does it mean? We have a room, say 6 by 5 in terms of dimension and 3-meter height. So this room, if you can make an imaginary box that fits that dimension, that is already a model. Now, this box that we made will have to associate how many surface area on the east wall that has brick wall, that has door, that has windows. So that imaginary volume which we have made is referred to as mass. So that will be our energy mass, but it will have to contain the properties of the physical building. So Revit will automatically generate this using the geometry of your architectural model to create spaces. You can define zone, then you can now set up how you want energy to be calculated and operated. Now, the key thing in this model is that your input data is very, very important. You must ensure that you put accurate data for you to get a reliable and energy simulation results. A lot of people will say, oh, we'd rather go for other software for load calculation. The Revit is never giving perfect calculation. Well, depends on your level of knowledge with it. So to a large extent, people are right because they are not able to go through the rigors, what it takes to get the right result. Then the model as well help you to understand the performance of the building. That's not only when you are designing for, when we're using all the other calculation software, we assume or we follow guideline in terms of lighting level, number of computers, number of people. We make a lot of assumption. But the Revit model, we actually use every element. If the electrical guy has added 13 power sockets or added 21 200 lux lighting, is going to actually take the real scenario to do the calculation, and performance will be reviewed at the end of the day. So, like I've mentioned earlier, the workflow is so easy. We have to be sure the geometry is correctly done. The geometry is converted to analytical model, which I mentioned earlier. The analytical model is converted to thermal surfaces. So thermal surfaces mean this imaginary mass, imaginary volume, which we have, but with associated property in terms of U value, thermal conductivity of those material. Then the system now can analyze the load and make a report for you. So this is what I have just explained here, understanding the geometry, the analytical model, the thermal surfaces, the system analysis, as well as the reports. Let me give you a hint. I will advise you to take a pen and a paper, jot points that are not clear to you, jot questions that you may have, jot ideas that are coming to you as well, because anytime I'm under a training, beyond whatever the presenter is telling me, some ideas start to come. So I always try to jot them. So it's just a tip for you guys to have very good use of this session. Okay, so let's look at the end-to-end workflow. We said we're going to create and validate the spaces from the model that we have, meaning the data like the volume of the space, the area of the space, occupancy, different internal loads, application, everything we have to make it perfect. Then we move to the next step by taking these different spaces and grouping them into zone so that we can select a system that serves different zones perfectly. Then we can configure the energy setting, whereby we will be looking at the building type, the location, the ground plane, everything that can impact the building in terms of load. We will configure that before we go to generate the model and do the validation. So this is all we're going to do in the session today. So step one, which is very critical, is the site location. Whenever you take any software for calculation, you may have the coordinate of your site. You may have just information about the city. Very good. So let's start from the city. If I go to Revit and I click on location, I can easily put a city. So let's look at a city that most of the people here are familiar with, Lagos. So if I put Lagos, that is a state. In Lagos, we have Epe, we have Ikorodu, we have Apapa. So if I go a bit further and specify Ikeja, the thermal load in Ikeja is obviously different from thermal load in Ogombo. So if I had Ogombo, okay, in Ogombo, maybe Ogombo is 15,000 square meter. Let's just assume. Where exactly is my project located? Are there high-rise around it, or is my project the highest in that area? I cannot define in this location and site. Now, if a surveyor already did a mapping and gave you the GIS data, if you have the exact coordinates, in this tab, you are actually able to go to the site tab and put that exact coordinate. But the truth is that the coordinate given by the surveyor is one corner of the building, while your site is not going to sit right on that corner. You are still going to have offset from those points. So I try to differentiate the 2 points which we're talking about. The first point you have is the survey point. This is where the surveyor gives you. This is your site plan. And your building is sitting here. So the survey point is so clear. This is the coordinate that you put into the location of Revit. Now, if this point is here, or here, or here, Revit does not know unless you specify. For every other calculation software, I don't want to mention name, you will only put in this detail. Yes, the moment you have this detail, at least I can tell you are well more than 80% correct in terms of solar load for that project. You are well above 80%. But the funny thing is that the 20% trend could change everything. For example, this is the longest span. If this span is facing east, the load will be different from this orientation at the moment, because this is just the part that is facing east. So if I know this point, then it allows me to place the project according to true north. So the first point you will see in Revit, we have the survey point and the project base point. Both are always together when you activate it. When we go to do the guided workflow, you will see that clearly. Now, summarizing everything I've mentioned, survey point is the real world coordinates that the surveyor gave to the architect. It's usually used by civil to cite their drainage, everything around the plan. It also controls the true north as well as shared coordinates. It's not ever moved because that is fixed. That is your plot. You cannot move your plot. But project base can be moved. You can change the orientation of the building. You can move it anywhere. For example, if you have more than 3 buildings on this site, so you are going to have different project base points for each of the building, right? So it's actually a site benchmark. While for the project base is an internal coordinate, which is used by us and the architect. So we do the north of this project in reference to the true north of the site. So usually you see this point where some grid intersect. Maybe the first grid here and the second, the first grid from here, if they intersect, usually this point is placed at such position. So what is the key takeaway here? The project base point is inside out. That is your inside reference to the outside point. While the survey point is outside in, your outside reference relative to the inside reference. I hope that is making sense. Okay, the step Two is now to prepare our model, which I tried to describe earlier. The architect has built up your building. You try to convert those buildings to just ordinary mass. That's imaginary cubes or square, cube relatively, which have similar parameters to the real elements. So this is what we try to do, whereby we can associate imaginary mass for the wall, for the floor, for the roof, for the space. That is what the software is going to analyze. It's also possible that the software can analyze the model itself. Something, okay, it's on Telegram, sorry. Now, what are the different types of models or analysis modes that you have? The one I've been discussing now is the conceptual. So conceptual mass means the building is converted into an imaginary volume. What I was discussing earlier, if you look at this cluster, if the green building happens to be my new project, you can see that all the other buildings already have casted shadow on it. So I'm going to have less load to deal with. But the orange building has like 3 faces or even all the 4 spaces exposed to sunlight. So if I was not doing the modeling based on actual site location and the surrounding building, if I take this building and apply rule of thumb, or I just do a calculation, the floor area are the same, the floors are typical. I can calculate for the ground floor and say, okay, maybe I have 100 kilowatts, and I apply 100 kilowatts on all the floors. What will be my error? You will find out that the floors at the topmost part will have load higher than 100 kilowatts because the lower floors have been shaded. Other buildings have casted shadow on them. So that's why it is good to set it right. It will be funny to say, oh, but the floors are typical. Since I got 78 kilowatts, I should use 78 kilowatts everywhere. No. The more precise and accurate your data input is, the more precise results you have. So this is when you use mass form, it allows for easy or early feasibility. Also, like I mentioned, you can use the original model from the architect, provided the architect use the right material with the right U values or R values, whatever value you have, the roof, the floor, the window. If the architect has model, not just about taking basic wall and putting the thickness or adding the thickness. If he has model based on the actual conductivity of those materials, you can also use this to do your energy analysis. But the simplest one is the mass form. Also, you can make detailed item where you have put in all the spaces, the application, where is a dining, where is a kitchen, where you have put in all those value in right detail. Then you can also make your calculation. So these are the 3 modes. So the most easiest mode is the conceptual mass, a situation where you convert the building to mass and assign material type. Actually, automatically the software will assign the material type from the model when it's converting the model to a mass form. Okay, next thing we talk about is the system zone. System zone are graphic elements which are used to assign area of the building that will be served by specific analytical system or zone system. For some of us who have been using Revit, we must have been hearing about HVAC zone. HVAC zone is different from system zone. So I'm going to try to explain. So you will see the tab system zone under analyze and energy optimization, while you will see HVAC zone under analyze and spaces and zone. Okay. The system zone can just be drawn as a line, meaning it will consider the different systems in different spaces that will be served by a particular equipment. So as we go on, I think I have a breakdown which will help you to understand. This is just showing the process how to create a system zone. Now, let's now look at the HVAC zone versus the system zone. So the HVAC zone is what is used for your load analysis. It's based on space. It's used part of your load calculation workflow. It defines the thermal load, the cooling load that you want. It also is created under the space and zone tab, which I mentioned earlier. And it's a logical grouping of spaces. So most time when you start your design, when you create a space, automatically Revit associates one HVAC zone to that space. So if you have 30 spaces, you already have 30 HVAC zones. But you can now regroup. You can remove a particular space from a zone, add it to another zone. While system zone is talking about physical zoning. For example, I have a 13-story building and I have AHU for cooling on each floor, but I have one AHU for fresh air to all the floor. So that AHU for fresh air becomes a system zone. So the zone is dealing with multiple HVAC zone. So HVAC zone is the primary, system zone is the secondary. I hope that is making sense. So the takeaway is that the HVAC zone is the ask, is the requirement for your thermal calculation, while the system zone is the solution, is the delivery meeting the requirement of the HVAC zone. Okay, so for you to really understand what we mean by the system zone or the HVAC zone, let's look at this layout. We have a building where the perimeter zone is just corridor, but the building is wrapped in glazing. And the core zone, it's filled with office desk, occupancy, equipment, and all what have you. So for you to understand, if you look at this layout, this corridor has no occupancy, but there is so much solar load from the environment into this space. So what it means is that the heat gain here will be due to solar gain and conduction. You need to cool this corridor. While if you look at the core of the building, that's where you have the office arrangement, people, equipment, and all what have you. So your HVAC load here is dependent on internal occupancy, equipment, and application, if it was to be a gym or a production ground whatsoever. So this means the results you will get on the perimeter will be different from the result you get in the core. And this now helps your system zone, meaning you can use a different equipment to cool the perimeter and a different equipment to cool the core. So you can have multiple HVAC zone, HVAC system on different, they are interwoven. I hope I'm making some sense on that. So this is just showing a simple geometry, trying to explain what I have said, meaning the different zone, you can have different temperature management, different humidity management, different control based on the application of the respective places. So from all this information put together, your energy model can now be created. So your building, which is the original model, can be converted to masses. And you will see when we go to the real software, you will see how the masses will come out and look like. So you can then run your analysis. You set your project location and weather data, you define your spaces with correct space type, you verify the zoning boundaries, then you can make input in terms of what type of HVAC system you want the software to consider in terms of ventilation rate, thermostat set point, heating and cooling, capacity. After that, you can run your analysis and the simulation will come out. You will have a load. So when you try to run the analysis, there are basically two options, which some of us will have tried and see. You have the HVAC system load and sizing. So the report that you will get here is about the loads in the building and the expected size of equipment to place in those respective spaces. So here you will go to the energy setting, make inputs like your floor, which one is the floor on the ground plane? Is it with semi-buried basement? Is it with ground floor? Is it with, so all this setting you can adjust to make sure. We will do this practically when we go into the practical session. And if you want a more detail, like I made the example of a typical floor, whereby the ground floor have shadow being casted on it, and the upper floor is standing out. So you may want to go to the advanced option and edit some of the parameters in terms of what is the percentage glazing. If you are using the building element, you don't need to add in this detail model. But if you are using energy mass, meaning you are telling the mass that, okay, from my overview, the building is 100% glazing or has about 70% glazing, the height of window, basically. So those kind of information you can put in the advanced energy setting. After that, you can run your analysis. The moment you run your analysis, you will come with about 4 results, 4 tabs. The first one, you will see that the software will report your surfaces. You know, you have changed the building model to analytical surfaces. So it's going to show you what are the type of opening you have, what are the type of walls you have, the type of roof, the number in terms of quantity of those type of material, and as well as their surface, surface area. It will report this. It will also report the spaces based on the type of space which you have added. It will show you the floor area of the spaces, the volume of the spaces based on the headroom. You will have these analytical spaces. It will also give you space ventilation schedule. This is following the ASHRAE standard. You can see the VBZ, the breathing zone. You can see the room required air by floor area, required air by person based on the type of space that you have recommended. Then it will calculate the ventilation air that is required for those spaces. Based on this type of floor space, by ASHRAE standard, there is a number of people per square meter. So it will use that occupancy rate to calculate or estimate the number of people. If you now have more than what it is given, you can modify and change the number of people. And that number of people is used to multiply the outdoor air rate per person, and you can now have a final result. And the next thing you see now, you will see your model coming as imaginary mass, volume that I have described earlier. They will come as surfaces, which will allow you see this result. These 3D graphics help you to know if the analysis is correct. I mean, if the model result is correct or not. If something is wrong, you will also see some warnings. And after that, you can now have your result in terms of cooling load per zone or per space. Either you are doing cooling or heating, you will see the peak time of calculation. You will see all the engineering checks in terms of capacity per floor, airflow per floor, airflow, number of people in that zone or space, and you will see the breakdown of all the sensible and latent heat as they amass to your final result. Then you can see how your cooling compares to heating and all the other things about the ventilation. You see the breakdown. So the results comes detailed. You can see everything by space or by zone. So that is the first option in your system analysis. The second option, which is annual building energy simulation. This is not just about the HVAC load. HVAC load will be a subset in this. This is going to show you all the pumps you have for your water system, all the electricity consumed by a number of TV, cameras, lighting, everything in the building. So this is going to analyze the total energy operation of that building in 1 year. So you can run your analysis, then you will see this result, which is the analysis report. It will show you annual overview of every system that you have in the project, the cooling, the lighting, the heating, interior equipment, and this can go further and further into different type of level of report. You will see comparing month by month what will be the energy consumption based on each system, HVAC, electrical, or what have you. This is an overview of the report you are going to have. So you will have the report of almost everything from January to December. Now, if you are targeting a certain compliance in terms of green building or LEED or BREEAM, you can also, if you have a licensed Revit, you can upload that result into Insight. Insight is a cloud service where you can have your carbon footprint evaluated to submit for green building compliance. And on that Insight, the advantage you have is that you already have your result. It can propose alternatives, you can propose options, you can propose type of material or type of system, types of architectural building material, structural. It can propose things that will optimize your design. You can come up at the moment now with, say, a load of 2 megawatts. And from the Insight, you might say, okay, if you change this roof from steel to roof deck, or from roof deck to arch, thatch, all these will give you this kind of savings or this kind of credit. So that's the last step of the process. Okay, what are the key takeaways? You have to understand how to set up thermal volume, surfaces, and spaces so that the energy analytical model can make best use of it for simulation. We have to put in the right and accurate information in terms of project location, weather data, thermal properties. You know, I remember in one of the classes, our moderator, Engineer Adebimpe, talk about GIGO, garbage in, garbage out. If those settings were not correct, if there are too many assumptions, your result as well will be based on a lot of assumption. Then you can use your dedicated system analysis for proper HVAC load calculation. So, best practices. When you have building that has large number of floors, it's better to use section boxes to isolate. If I have like 18 floors now, that file is big already. So I can decide to make it into 3 sections. So I can do ground to 4th floor as first section. After that, move to 5th to 9th floor or like that. So I can do as segmented calculation. Then for the zone and system, is so critical. You need to know your HVAC zone correctly. For example, you cannot put bedroom area and kitchen area together on the same zone. You can, but it's not efficient. Because in the kitchen, you are doing a lot of extract, you need a lot of makeup air. In the bedroom, you're doing almost like just a recycled air system. So these are the understanding you need to get the correct system zone and correct air delivery. Excuse me. So what are the common mistakes that we make that turn people off to say, forget about the calculation in Revit? The first one is that if we don't bind or make our model totally closed, that means there are leaks. You know, I talked about making an imaginary mass. So if this mass is not fully closed, then you are having a skew thermal performance result. It means there are leakages. Where you are supposed to have 3 kilowatts, you may end up with 8 kilowatts because it's realizing that it needs to fulfill the need through that leak. So all your energy is leaking out. Also, if you overlook spaces like your room, roof plenum, or shaft in the toilet or shaft in the electrical room, all those also will affect your calculation. So it means you have to be meticulous about those details. Then a great one is incorrect weather data. From the start of this class, I talked about how just talking about, okay, this project is in Ikeja. Oh, this project is in Ikosi. Where in Ikosi? What is the environment looking like? Is it 300 meter above sea level? Is it minus 50 meter below sea level? All those informations are required. So if you don't have it, you are making a lot of assumptions, and the calculation will be based on a lot of assumptions as well. Then you try to make sure that you reduce complexity of your geometry. Like I made an example of an 18th floor. If I have a super machine whereby the configuration is super good, yeah, I can go ahead and run the complex geometry once. But if I know the limitation of my machine and I don't want it to always crash, then it's better to make some section boxes. I think with that, we're coming to the end of the theory part. So this is just a cheat sheet for you. Prepare your geometry properly, which I have said over and over. Make sure you make right inputs in terms of data that the software will need for the calculation. Then you can perform your system analysis while you check for any warning or error, revalidate your result. And if you have the advanced advantage, you can review the entire result in your Insight dashboard. So I think we can have coffee break. How many minutes have I spent now?
I think you spent like 43 minutes, if I'm right. 43 or 40 minutes. So can we do, yeah, see you in 15 minutes. Can we do the 15 minutes or, yeah, better. So we will be back by, how long will that be? Let me round it up. By 10:10.
Okay.
Is 10:10 fine by you, sir?
Yeah, it's okay. Let me to grab some
Or
coffee.
does anyone have a question based on this?
Yes, sir. Thank you, sir. Hello. Can you hear
Okay.
me?
Yeah, go ahead.
Yeah, we can hear you.
Okay, sir. Please, I want to know what embodied carbon.
Sorry?
What it means. Embodied carbon.
What bit carbon? Okay.
Yes.
Is a credit measure. That's another topic actually entirely. It's you know, when we are talking about decarbonization, what we are interested in is better to use natural means of energy or power, so to say. If you can reduce your use of fossil fuel like petrol, diesel, in the Western world, the natural gas and fossil fuel, they are quite so cheap than electricity. So they want to maintain the use of fuel for their boiler, for their heat energy. But to reduce the carbon footprint, they are advising that, okay, you move to either inverter, solar source or wind source, or so the activity has now been determined to say, if you can do that, you get a carbon credit from the government, just to encourage people to say, okay, you move away from combustion engine car, from cooking gas, everything to electricity or natural source energy. So there is a term in this regulation, which is referred to as carbon morbid. But like I said, if you want to really break it down, it should be a separate class where we can look at all the components of carbon footprint reduction.
Okay, all right, sir. Just that I was asking because I've done an energy analysis on a Revit model before. So it now gave me embodied carbon section. So I now saw that the carbon footprint. So I just want to know the relationship between the embodied carbon result I got from the analysis as it relates to HVAC.
Okay, embodied carbon are based on the material, the system you are using on your project. So meaning if I choose a boiler, a gas boiler, I already included some carbon, which I cannot separate from my analysis, even though I'm asking optimization to reduce my carbon footprint. So I already included, but instead of that gas boiler, if I have introduced electric boiler or solar powered boiler, I have reduced my embodied carbon already.
Okay, I think I get now. Oh, yes, sir.
Yeah.
All right, thank you,
Thank
sir.
you, sir.
You're welcome.
Okay, Wally, Tayo.
Yes, sir. Thank you for this time, sir. We really appreciate it. Some of us are new to Revit, some of us are new to this industry, and I just want to start from there, like, so you can know that if I ask a question, I'm asking from an amateur.
No problem. there is no stupid question when it comes to my own class. Everybody have opportunity to learn. I'm also learning when I'm talking with you guys.
All right, sir. Thank you for this opportunity. So my question is, this analysis, energy analysis, is it actually for our heat and cooling load calculation, or because I see some people use HAP software and the likes? So is it part of the heat load calculation, or what? So I just need the clarification on that, or is it a separate thing entirely? And the second question is, at what point do we do this analysis?
Very good.
So is it when we start the project, when we get our project location, or at what point do we actually need this analysis to be done?
Okay.
And
let me answer from the first one. The first one is that if you follow the slide properly, I told you that the energy analysis tool has two options. The first option will only do your cooling and heating load calculation. All you are interested in is just the cooling and heating load. Then the first option is HVAC load. That ends there. The second option now is energy analysis. Now, when we talk of energy, it's not only your cooling system that is consuming energy. Everything in the project consumes energy. So if I now link it to your second question, it means that when you get a project, the architect and the client says, give me an idea, which we call concept design. Give me an idea what my building load or my HVAC system will be. So you can use the conceptual mass without the input of all the electrical guy whatsoever, just specifying what the building look like, what is the potential use. At that time, the software will use guided value on ASHRAE table that, okay, if this room is a gym, you expect to have this amount of lighting level, you expect to have this amount of occupancy, you expect to have this amount of activity. So it will use that guideline to generate a result for you. So you can say, okay, this project, we are going to need 2 megawatts cooling, 2.8 megawatts heating. So concept-wise, you have advised the architect and the client. Now, when you want to do your design, because for you to now place your air terminals, your terminal unit, you need to do proper calculation. So then you have to add all the right U value, R values, every thermal conductivity that will happen. Then you can have a proper calculation with all the airflow requirements, the set points you want, the humidity you want to maintain, everything. You can configure it, and the software registers that and uses it in your design. Now, when the entire design is completed, electrical has done its own, plumbing has done its own, firefighting has done its own, you can now do energy analysis, where you see all the power connected in the building. At that point, the subject of embodied carbon, like someone asked, will come up. You will see all those results being analyzed. So if you are targeting a particular lead compliance or brand, you already have guideline of what in the optimization you can say, okay, this is my target. So that target now help Insight to reassign or regroup some zone and say, okay, if you want to achieve this, you have to change this, you have to introduce this, you have to add this. I hope that answers your question.
Yes, sir.
Okay.
Thank you, sir.
Okay. Sir.
Hello, sorry.
Good
Michael
afternoon,
Jude.
sir.
Michael Jude. Hold on, please.
Yes, sir.
Hafiz Aziz first. He raised his hand before you.
All right.
Yeah, thank you very much, sir.
All right. Okay.
Thank you very much, Engineer Olufemi Oni, for
Yeah.
the wonderful presentation, sir. I have a question regarding the practical application of the Revit systems analysis. And my question is just like, I just want to know, can this workflow be directly relied on for final equipment selections and design load calculation, especially for systems that are using commercial plays and pharmaceutical projects? So considering the parameters like ACH rate and some other factors that need to be considered, especially the prioritizations and some other things. So that's what I'm trying to be concerned about.
That is yes. When we go into the practical part, you will see how those are set up and how you can achieve it.
Okay, thank you, sir.
Okay.
All right,
Yeah.
Michael Jude, then you.
Okay. Good morning, sir, Engineer Femi. So my name is Jude, and so far, although there was a point in time my network broke off or so I don't know if this was covered there, but I'll ask anyways. So initially, I'm just getting to know that you can actually use Revit for your load calculation. So then I usually use other softwares to the popular HAP and the rest. So I don't know if you've said it before. Like I said, I don't know because there was a point I was off. But then in the process of when we are now going to generate our reports and everything, are we going to get our airflow requirements? That's okay. The airflow requirement that is required to cool that space along with it.
Yes. Very good question. The first thing is that when you do the report I shared must be very, very blurry. Maybe it's not so clear. Everything is there. Not only there, the good thing is that since the software has created a space schedule, the calculation that it has done, anytime you click a space, if you go to the property, you will see the sensible, the latent, the airflow, the set point, everything about each space will have been automatically associated. So the advantage in Revit is you don't have to now start looking at your schedule of reports. What airflow do I need in this space? So also Revit allow you that you can create a responsive table. What do I mean by responsive table? I can make a space schedule, put in the airflow, create a formula tab where I will say that, okay, anytime I put in air terminal in this space, compare the calculated airflow to my actual terminal airflow. So let's say a space have airflow of 300 and I place a terminal with 235. So I can create a formula table saying when you subtract these two, when it is outside minus or plus 15 liter per second, please flash me. So if I go to that space and place 3 air terminal, you calculate the total sum of the airflow on the 3 terminal, compare it to your load calculation result airflow. Then it will tell you that, okay, now you have 100 liter per second in excess compared to what is expected in that airflow. So I can do that formula table and make it color code. I'll put a color that whenever this difference is between plus or minus 25, plus or minus 50 liter per second, you will just see the table showing that column with the exact value of excess or the rated value and color it in red. Say now you are out of design airflow for this space.
All right, sir. Thank you, sir. I think I'll just take these two last questions in the chat box. Then I would. It's a common question, and I think it's still a question that people ask every now and then. What can we do in case the architect did not provide the properties of the building material, like walls and the glazing, etc.?
Okay. You can answer that, or you want me to answer?
Please answer the question.
Okay. Originally, I said we're using mass. So if you use conceptual mass, the mass will take attributes from that wall. If that wall is 150 mm, all you can do in that advanced what's it called? Advanced tab in the energy setting, there is where you have what is called schematic. On the schematic, you can go to say, all my external wall is going to be 150 mm concrete wall or lightweight wall. So the specification that you have made for you and I, we know in the industry, most of the external wall are 230 mm, except where special cases they go to 300, and most of them are hollow block. The partition usually are like 150. So if your architectural plan is different, then whatever you see, you can make. Now, we end up, that I know in Nigeria, we end up with light external wall. I've not seen people who have painted their house maybe in purple or black or whatever. So you know what will be the reflectivity. All those ones, the moment you specify in the schematic, what is the material? What you will end up having is that the way you specify the material, the software will calculate a U value, which will not be, it cannot be 50% away from the true U value of what you want. So I can tell you well over 75% will be correct in terms of the U value. So these are the things you do. Glazing, for me, even if the architect says we're using double glazing, triple glazing, for my calculation, I will use single glazing. Single glazing will give me worst case, meaning by the time I'm doing optimization, I can now save. But if I go ahead and use triple glazing or double glazing that he has mentioned, and the client now say, I don't have money for that kind of glazing, I want to use single glazing, then I will have shot myself in the foot by communicating a wrong load. So these are the kind of things you do in the schematic. I hope that answers that question.
Yes, sir. Let me just, I want to say something because of what you said now. And because it's a common question, as you're asking the question, a thought came to mind. I think we need to do, I have to do a topic on understanding engineering material for HVAC engineers in Nigeria. I think you guys can follow me up on it, that I said I want to do it. But another thing you have to know is that, like he's saying now, you understand what he's saying? You know, if you deep down in and ask him more questions, you know the materials we use in Nigeria as an engineer. You know the common building materials that you have. So those things will guide you to make some assumption, which, like Untitled taught us, you then ask your architect, since he did not supply it to you, then you will then have to tell the architect that these are the assumptions with which I made my designs. You understand? So I think we need to do so as to improve people's confidence in the use of it's not necessarily Revit now for cooling load calculation, also app, because it's also a challenge that I think we have common in our industry. Thank you for your answer to the question. I'll answer the last one, please. The energy calculation, is it an inbuilt app on Revit or a plugin? What are the similarities between app, carrier, and all those things? The things you have mentioned, app and carrier, they're the same thing because app was done by carrier. App means hourly analysis program. Then it's not a plugin. It is part of the Revit software, and it has undergone so many changes and to improve the veracity of its results and values. So I think it's also a good software, like Engineer Femi has said. It's garbage in, garbage. Even if you use app, it is still garbage in, garbage out. So I would also try and introduce all of us on this group to a Telegram group created by Engineer Femi, where we have some of these app carrier software. Then we did Evercom too, where we did Evercom and all of those things. So the videos are on the Telegram group. You can also join that group and go to the media session to get some of those things. I think our time is fast spent now. we need to close now and come back by 11:25, guys. Someone's hand was up earlier. Samuel, I think I'll just give you 1 minute. Make your question very brief. Samuel, along.
Olusegun, thank you.
Right.
You've asked the question. It is the same question the person asked that you read out that I wanted to call his attention to.
Okay. All right. Thank you, everyone, for joining. Please stay tuned. Don't go. You see that it's going to get more interesting. What you have seen is just the theory. Let's go into the technical side. So we come back by 11:25. 11:25. All right, sir. Thank you, sir. Thank you, everyone. Stay tuned. Don't go away.